In this video, we will discuss LAN switching segmentation, LAN switching operations, and LAN switching cut-through forwarding. LAN switching segmentation. LAN segmentation simply means breaking one LAN into parts, with each part called a segment. The term LAN segment comes from the original use of a physical bus with 10 base 2 and 10 base 5. A single Ethernet segment consisted of the devices connected serially with coaxial cable. When 10 base T came along, the term segment was still used, this time to identify a hub with multiple devices connected to it. LAN switches can be used to segment networks into logically defined virtual workgroups or VLANs. This logical segmentation, commonly referred to as VLAN communication, offers a fundamental change in how LANs are designed, administered, and managed. Logical segmentation provides substantial benefits in LAN administration, security, and management of network broadcast across the enterprise. Segmentation using switches. LAN switching employs microsegmentation within switch hardware, which segments the LAN. Switches usually allows multiple conversations or traffic between two ports to occur simultaneously. LAN switching operations. LAN switching is a form of packet switch used in local area networks. LAN switching is performed using hardware at the data link layer. Because LAN switching is hardware-based, it uses MAC addresses, which are used by LAN switches to forward frames. LAN switches provide much higher port density at a lower cost than traditional bridges, which allows LAN switches to accommodate network designs featuring fewer users per segment or microsegmentation, thereby increasing the average available bandwidth per user. Switches can use three main forwarding techniques as follows: store and forward switching, cut-through switching, and fragment-free switching. Store and forward switching. This LAN switch forwarding method copies the entire frame into the switch buffer and performs a cyclic redundancy check or CRC for errors within the frame. Because of the CRC, this method of forwarding is the slowest and most processor intensive. Cut-through switching. In cut-through switching, the frame header is inspected and the destination address or DA of the frame is copied into the internal memory of the switch before the frame is forwarded. Because only the frame header is inspected before the switch begins to forward the frame, once it reads the destination MAC address, this forwarding method is very fast and reduces latency, which is the amount of time it takes a packet to travel from source to destination. Fragment-free switching. Fragment-free switching waits for the collision window, which is the first 64 bytes of a frame to be accepted before forwarding the frame to its destination. The fragment-free switching method holds the packet in memory until the data portion reaches the switch. This switching method was developed primarily to address and solve the problem encountered with late collisions, with occur when another system attempts to transmit a frame after a host has transmitted at least the first 60 bytes of its frame. And lastly, LAN switching cut-through forwarding. Cut-through switching, also called cut-through forwarding, is a method for packet switching systems, wherein the switch starts forwarding a frame or packet before the whole frame has been received, normally as soon as the destination address passes. Compared to store and forward, this technique reduces latency through the switch and relies on the destination devices for error handling. Pure cut-through switching is only possible when the speed of the outgoing interface is equal to or greater than the incoming interface speed.